Well, progress with the Weeden No.8. It's all back together, and it now has a steam pipe. I'll close in on that and you can have a quick look. Unfortunately, I had to make a new steam pipe for it. When I was refitting the old one, I very gently tried to bend it because it wasn't really lining up properly, and it just cracked. I think it's just fatigue because it's so bloody old. You know, the metal had just hardened. So I made a new steam pipe. I've located it at this end using some chemical metal to hold it in place. Like I said, I don't want to apply any heat to this casting because I'm fairly certain it will just melt, basically, so no soldering. This end, this was roughly 1/4 inch, the boss that was sticking out of the safety valve hole here. And I found a pipe union nut that was roughly the right size, but the thread was different. But fortunately, this is so soft, this stuff, that I just used the pipe union nut to cut a new thread on the boss, and that worked quite well. The only problem was that this is quite a large union nut, and the correct size ferrules I had for it were the wrong size for the pipe. So the ferrule is a little bit over large compared to the pipe, but yeah, it's not really a problem. It's all in there nice and tight, and it's done the job. Now, once I got it all back together, this brass plinth was still quite loose. So I just made up a little tiny brass block shim here, which wedges between the plinth and the firebox, and now this is rock solid. It's not moving around at all. You probably can't see it, but I also did the same thing for the beam assembly. There is a very, very thin shim just underneath here, because this was flopping around. No matter how tight you try and bend the tabs, this was flopping around all over the place, and it was just, there's still a little bit of play in it, but nothing like what it was. So like I said, there's a very thin strip shim of brass in there that's holding this steady. So yeah, I think that the assembly and everything is pretty much done. Which leads us to our next problem. What am I going to do about this? Well, what I'm thinking that I might cut off the remainder of the pivot boss here, so that I can then file this part flat and then make a new boss which I can pin, drill a small hole in this and then pin to that, and then with the brass rod I can make a new pivot head for it, which will then I can stick on there like that. That's my theory at the moment. I mean, it won't look quite right, but at least it will be functional and should be reasonably strong, and then we can make the proper plug and the lever arm for the weight for the safety valve. So that's the next operation. Okay, so only about half an hour or so on the lathe and the little Sherline mill, and I've come up with the replacement pivot piece. First chance to use my new slitting saw. I bought a 2.5 inch diameter slitting saw for the Sherline mill, and it did a lovely job on that slot. Superb. Now I will close in on the top of the safety valve mount, and we'll have a look at what I'm planning to do. Okay, so as I said, I cut off the little piece that was remaining and filed that flat, and let's just tip this up so you can see. I've drilled a little tiny hole, hopefully roughly in the center of where that pivot used to be, and I have I'm going to use an old blunt 1.5mm drill bit that goes nicely in that hole, and then there is a mating hole in the bottom of my new pivot, and that will all be Loctited in place. So yeah, hopefully that should do the trick. Then we can move on to the weight, making the pivot arm. It shouldn't be too much of a problem. And while we're on the subject, here's a little workshop tip. I'm sure that you will do this, but for those that don't, it's well worth saving broken drill bits, taps, even small needle files, because they can be extremely useful. Now I'm going to use an old 1.5mm drill as the pivot pin, as the locating pin for this thing that I've just built, the new pivot point for the safety valve. The point about it is, the vast majority of what's in this tin is high-speed steel, so that's bloody useful. You can make old drill bits. There's a really knackered old one, right? That can be ground down. You can grind down one end of that and make that into a transfer punch. the small drill bits that are broken, they are excellent. They make excellent pivots, pivot pins for all sorts of different stuff. You can grind down old needle files and make perfectly good blade, a knife blade out of that. So yeah, there's 101 uses for broken drill bits and taps. So hopefully you won't have many, But yes, I always do tend to keep those that are blunt or broken or just simply worn out, because they can be used for all sorts of other things. So good tip. Well, we're getting very close to the moment of truth. The safety valve assembly is all finished. I'll close in on that so you can have a good look. Yeah, there's always tricky in machining small items, and this is where your ER16 collets really come into play. So the safety valve weight, I simply cast that out of hard lead. That's lead with a high antimony content. I basically just made a wooden mould, for want of a better word. Then I used 1/2 of one of my smallest sand casting flasks, packed a load of sand into casting sand into it, and then just pushed the wooden mould in, and that you end up with that's what you end up with basically. I didn't even, it was an open sand cast, but it came out quite well. And the nice thing about this hard lead is that it machines really well. It machines just like aluminium. So you see the underside there. So yeah, so this is free to lift up. There's the plug you can see that goes into the hole, and then basically you flip that out of the way and you can put your water in through there. So yes, it all came out quite nicely. It looks good. Whether it's going to work, of course, that is another question entirely. But yeah, it's all come together quite well. I'm quite pleased with the way it's all turned out. Before we get on to steaming it, I'm going to bring in another one of my Weeden steam engines, which I restored a few years ago. Now this is the Weeden 49, and the reason I brought this in to show you is because I believe that the burner in the 49 is very similar to what would have been the burner in the number 8. So if we open this up, flip open the door, and we'll have a closer look at that. There you go. So that's what I believe the burner in the number 8 would have looked like. It might have had a flat wick which was adjustable rather than the two round wicks, but it would have been something very, very similar to that. Obviously with the 49 it's attached to the door, which I could take it off, but I'm going to use a gas burner in the 8 anyway. So I thought you might like to see that. Well, all there is left to do now is put some water in it and get some heat on it and see whether it will steam. Well, this has been a bit of a bugger. We're back with the Weeden No.8 again. Now, I've had 2 attempts to steam this and both of them ended in failure. And I'll take you through what actually happened. So, first of all, first attempt, massive steam leak from the whistle. Water and steam pouring out the whistle, the valve wasn't doing anything. So I bound the whistle up using some PTFE tape. I put some heat shrink tubing over the top and I put some PTFE tape around the thread on the whistle valve. And then I had another attempt to steam it, and that was fine. That my safety valve appeared to be holding, but then we had a massive steam leak and water pouring out of the bottom one of the elbows that held the sight glass. So at this point I thought, right, no, I'm going to do some investigations using some air. So what I did was I made up an adapter to go in where the safety valve fits. It's just got the right taper on it, and it's just got a little bit of copper pipe. So basically I can just remove that, flip that out the way, pop that in there like that, which is what I did. And I connected my compressor up. Now if you remember back when I first tested this and I put air directly into the cylinder block here, the engine ran fine, and it would run down to about 10 psi, no problem at all. So there's obviously nothing wrong with this. But now we're putting air in here and we're relying on the boiler to hold pressure. So what I found was that yes, I could get the engine to run, but I needed to put at least 20 psi in here. So there's obviously some sort of massive leak. So it was obviously there was air coming out of the bottom elbow of the sight glass. But I also noticed, as I was doing this, little bubbles of water slowly appearing at various different points around the base of the boiler. So basically the boiler was leaking from multiple spots where it's soldered to the firebox base here. And that, of course, rather created a serious problem. Now, resoldering the bottom of the boiler, that was dead easy. The problem was that I was fairly certain that the sight glass elbows, and there's one of them, were cast from white metal, which is, I think, all the castings are white metal. And I figured that in order to get the base here hot enough to resolder it, the sight glass elbow was going to melt. So I removed the sight glass, managed to get the nuts undone without breaking it, and went forward. I could have tried pulling these out of the boiler. I'm sure if I'd have tugged hard enough, they would have just come out, but then they would have been all squashed up, and it's so soft, this stuff, they would have been destroyed anyway. So I thought, well, I'll be careful and see what happens. But no, sure enough, as I flowed the solder around the base, the bottom elbow started to melt. So I took the decision at that point to remove the sight glass completely, and I've put a couple of small brass bungs in the holes to seal it up. I know it's a shame because it would have been nice to have had the sight glass, but I'm prepared to sacrifice that to get the engine running. So since doing the repair on the boiler, I have put my air adapter in, got my compressor on it, and now it will quite happily run down to about 10 psi. And hopefully that means that the boiler is now sealed properly. I've turned the air supply off here, and the pressure rises, so I'm assuming that the boiler is, I've had it up to about 25 psi, which is way higher than is necessary, and it was holding fine. So I think now, hopefully, we should be able to steam it. Okay, this has been an absolute bugger to run on steam. There's a lot of problems with it. I got it to run on air. I got it so that it would run down to about 6 or 7 psi on air. I couldn't get it to run on steam. And basically, it's just the age of the thing. I don't know whether you can see it. We'll close in on it. I've got the heat on now, but if we close in on it, one of the problems you get with steam, which you don't get running on the thing on air, if we close into the cylinder, I don't know whether you can see it, but there is some little tiny bubbles appearing around the end cap. And basically what happens is when it gets hot, the end cap starts to leak, which it doesn't do under air, obviously, because it's not getting hot. And that's just one of the problems. Also, I don't know whether you can see it, but there is a link, a horseshoe type link here, kink in the rod that drives the valve plate, and that's how you adjust the valve timing. And after playing around with the engine a lot, the valve timing was very definitely out, and I had to spend quite a bit of time fiddling around with that, making minor adjustments, to get the thing to run. And I basically got it to run as best I could under air, and made some more adjustments, but hopefully now it will actually run under steam. Well, I think we're nearly there. Nearly. Yes, there we go. Under steam. Amazing! Once you get it right, it's fine, but my God, getting it to that point, oh dear. I've literally spent days on this. Weeden's only true beam engine, at least 113 years old, running under steam. Oh, just so pleased to get this thing finally running. Amazing, isn't it? And my homemade safety valve bung is working fine. As you see, I had to patch up around the top of the boiler here. This was also leaking. There's no way I'm going to solder, because if I get any heat near the safety valve mount, it's just going to melt. So Yeah, so chemical metal is not pretty, but it does the job. So there we go, the Weeden No.8 under steam. Amazing. Oh, you just... I'm just so pleased about that. Change the angle. I don't want to move it because if I disturb it, it'll almost certainly stop. Well, I hope you've enjoyed this. I mean, it really has been a bugger to get this one going, but we got there in the end. Leaky boiler, wrong timing, leaky cylinder. My God, everything on this one. But it's running under its own steam. God knows how long it's been since it last did that, but there you go. Okay, well, let's quit while we're ahead. It's still running. I'll leave it at that. Hope you've enjoyed this series of videos on the Weeden No.8. As I said, one of my possibly oldest steam engines, at least 113 years old. I'm just so pleased to get it going. So, thanks very much as always for watching. Cheers!